Hey Griffin, so we have day 12. We're going to be talking about sorting networks today. You also have another article here to read and then answer some reflection questions. So you can listen as I read this article for you. As we use computers more and more and the amount of data we use increases, we want them to process information as quickly as possible. One way to increase the speed of a computer is to write programs with fewer computational steps. Another way to solve problems faster is to have several computers work on different parts of the task at the same time, which is what this unit explores. Unfortunately, it's not always that simple to just split the work among separate processors. Sorting networks are used to sort values in ascending order by comparing pairs of values. Unlike a conventional sorting algorithm, a sorting network can have more than one comparison happening at the same time. For example, in the 6-number sorting network that we use a lot in this unit, a total of 12 comparisons are used to sort numbers, but up to 3 comparisons can be performed simultaneously. This means that the time required that will be the same as what one computer could do by itself would take to make only 5 comparison steps. It is a bit like the situation where you might need to type in 4 pages of writing. If you have 4 people typing at the same time on 4 computers, you could probably get the typing done 4 times as faster than if one person did all the work. A parallel sorting network enables us to explore how much faster we can sort the values into order if we can make simultaneous comparisons. The main 6-way parallel network used in these lessons sorts a list of values more than twice quickly as a system can perform one comparison at a time. Not all tasks can be completed by using parallel computation, however. As an analogy, imagine one person digging a ditch 10 meters long. If 10 people dug 1 meter of the ditch at the same time, the task would be completed much faster. However, the same strategy could not be applied to a ditch 10 meters deep. The second meter is not accessible until the first meter has been dug. And for typing our 4-page document, if you have 400 people helping you, you'll probably spend so much time coordinating with all the work that it may not be very fast at all. Computer scientists are still actively trying to find the best ways to break problems up so they can be solved by computers, working in parallel, finding out how much and which parts of the computation can be done at the same time, and which parts have to be done one after another. In these lessons, we use a fun team activity to demonstrate a parallel approaching sorting. It can be done on paper, but we like to get students doing it on a large scale, running from node to node in the network. As an aside, although we call this a network, it is only one of the many different types of networks that we encounter in computer science. A common kind of network is a communication network, such as the telecommunication networks that mobile phones use, and of course the internet. There are also networks for representing things like road maps and airline routes. It is important to recognize that the sorting network is not one of these types of networks. It is a comparator network because it's a network where each node compares 2 values rather than linking different devices together. To use sorting networks, students need to follow simple algorithms and should recognize that if they do not follow it precisely the way that a computer would, then they will probably not get their correct result. Students will be working collaboratively to ensure that each part of the algorithm is coordinated, because if one person moves too far ahead without stopping at the nodes as they are meant to, it can cause the process to fail for everyone. There are also many algorithms that can be used to construct extremely efficient sorting networks of different sizes, and computer scientists study these to try and create even the better ones. These can be very complex, however, so when students construct their own networks, they will be doing this in a simplified way. So you have some reflection questions to complete in complete sentences. What is a sorting network? Is the internet a sorting network? Why or why not? Why are parallel sorting networks faster than a single sorting network? Go ahead, get started. Good luck.